So my great pleasure to chair this seminar. And this seminar is co-organized by ARC Research Hub for Energy Efficient Separation, MSA, and MCMR. And many of you might know actually we organize the regular seminar, and hopefully actually you can enjoy our webinar series and to engage with the expert in the membrane field. Just to let you know, actually, particularly for if you are not speaking, could you mute yourself and when our speaker to give a presentation. And also actually, you can put your question to the check box, and even actually when the speaker is talking, you still can put. No need to wait until the end of the presentation. And today's our speaker is Dr. Jing Guan. I think many of you know her very well. She's I think internationally recognized expert in the membrane field. She has actually over 30 years, I think, experience in the project management and the R&Ds. She made actually great contribution to apply the membrane technology in many fields, like the water treatment, drinking water production, and wastewater recycling. She led many actually large national or international research projects. And she also, even though actually she worked in the industry, she is very active in reviewing the scientific journals. So please join me to welcome our distinguished speaker, Dr. Jing Guan. Dr. Jing, Dr. Guan, you are ready? I hand it back to you. You can start.
Thanks, Yuan. Thank you. So good morning, everyone. I'm Jing from Orange Water Technology. Thank you, ARC Research Hub on Energy Efficient Separation for giving me the opportunity to present our work here. And now I'm going to share our experience on membrane application in different water area with you. So as we all know about, there are three major global problems in waters, but it's difficult to solve the problems using conventional treatment process. But membrane technology can do the job. So let's have a look at how membrane technology can fix a problem. So when we talk about the three problems in water areas, one is a contaminated water. So water is dirty and then become less and less. So in this area, I think we probably know about membrane technology. Now just many countries use MBR technology with microfiltration or ultrafiltration to treat those water and make the possible about effluent can be reused or recycled. And for the water scarcity, so we can use membrane technology plus nanofiltration to have an effluent with a very high quality water, meet a very high quality standard. And for the unsafe drinking water, so we can use ultrafiltration plus nanofiltration membrane technology to fix the problem, like this conventional treatment plant cannot do the further and deep treatment. So as we know about like membrane technology significantly contribute to the solution for solving the above three problems. So in this talk, I will talk about like one by one about how membrane technology actually has been applied in different water treatment. Part one, where I'm going to talk about MBR development, and part two about nanofiltration, nanomembrane, and its application, and also talk about membrane chemical reactor. That's kind of a membrane combined with other method to do the better job. So especially in China, the problem that the water actually got the water pollution is really serious. So membrane technology actually has been like rapidly developed and also applied in many cities and sites. So I just collect some data from just up to 2019. Actually, in China, there's 19 million cubic meter per day production from MBR treatment. Just because the effluent quality in MBR process is really good and also can meet high requirement. For example, after MBR treatment, we can have the effluent with organics at 23 milligram per liter, which is like meet discharge as standard. Also can be reused. Also about like some other item like ammonium is about like 0.8 and total phosphorus is 0.1. But total nitrogen is not as good as we thought. But we still can use some other method to do the deeply treatment and meet like further requirement. We just talk about like Chinese, the situation in China. So that here I just talk about like use the Chinese yuan to measure the membrane marketing potential. Just because many applications in China, so we also see many membrane production factories or company established. So from 2000 to 2015, just talk about like MBR unit, the price, the investment just reduced 70%. It's unbelievable. It's really just good for MBR development. And also about like the modification of membrane module and the membrane unit, we will see there's a lot of change and lots of development. So a large scale of membrane module, just that we can see from initial small unit, I just can't see it, about like surface area from 5.4 square meters. Now just we can see the big membrane module developed in Orange Water. Actually it's about 35 square meters. And about the unit, the MBR unit, also the capacity from 500 cubic meter per day, now just we can just increase to 1,500 square meter cubic meter per day. They all just meet like the requirement for MBR application, and also just have done very good job in the wastewater treatment and reuse. Now let's talk about the membrane material development. To make that high spread, back to the last. To meet this requirement for MBR in MBR process, we need high flux and high strength, and also anti-fouling. Those requirement actually we also need to just consider about like membrane develop probably is the key issue for to meet those requirements. So the membrane material developed from simple hollow fiber membrane, then just some modification for the strength. So just have some like hollow fiber, just have some long fiber just reinforced within the inner structure of the membrane. By now, we just developed the reinforced hollow fiber membrane, so with very strong membrane fiber, so we can those membrane can suffer from that very bad situation in wastewater treatment plant. And we also developed the membrane style. So from the initial about a flat sheet and also hollow fiber, now just we developed the corrugated membrane style. So I talked this one before, just like this kind of membrane just can, they can combine the advantage from flat sheet and also hollow fiber membrane, and then just make sure just the operation at high flux, and also can suffer from those membrane fouling. And also it's flexible to design the MBR unit with corrugated membrane, so we can totally depend on the requirement from different site and different including weather, the treatment site condition. And those development of the membrane unit has been used and applied in China for the different purpose and different treatment plants with different structure, like have 2 layers, 3 layer, and also 4 layers. And you can see that at the wastewater treatment plant, it use very high mist liquor, and also have a pretty good operation flux at above 20 element H. And this corrugated membrane we also applied in Australia, and working with Professor Song in UTS, used to nutrient recovery from urine system. And it's working very well in the pilot scale. The other membrane we have developed is kind of just modify the operation process. So it's kind of like a vibrating membrane. It's not only for the membrane style, also I consider about the membrane working situation. So vibrating membrane we design for some like high solid content, and also just to minimize the membrane fouling. So conventional membrane, we use aeration and also have a high power consumption. Well, if we just use a mechanical shaking, just we shake the membrane rather than like just use a bubbling. So actually we can reduce the power consumption something about like 50%. Here's the working principle. So in conventional membrane, actually membrane module is a steel. So we use like air bubbling to remove those particle or any fallout from membrane surface. Well, if we use a vibrating membrane, so we keep we just do not disturb anything for water. We don't need that high power to disturb the water. We use like mechanical shaking, just shake the membrane to make sure no any, just remove those fallen or solids from a membrane surface. So here's a small video which I can show how it works. So it's working very well. This vibrating membrane has been developed from since 2016. Now just we already finished established the water treatment plant at capacity 7,500 cubic meter per day. So those is about membrane MBR, membrane development for MBR in wastewater treatment and reuse. Now just we talk about the nanomembrane and its application. So in China, we classify water as 6 levels. I think similar classification in different countries. So the first one to the first level to third level. So those 3 levels is they can directly use as a drinking water source. Well, right-hand side, the level 4, 5, 6. So they have a they actually pollute. It's a contaminate. And also just we need to do wastewater treatment. For example, for the level 6, definitely we can't use this water for any purpose. So we have to treat water. But conventional treatment plant only can do the, like, for example, they can remove those organics and also solids, and then the water probably can discharge back to river. Then probably for another 5 years, and then we can use that water for water source. But if we do MBR membrane technology, so actually we can get the high quality effluent almost immediately after discharge. So in this process, if we do for the level 6, we do a conventional activity / biological treatment, and also plus MBR membrane process, then we can get the level 4 water easily. But after that process, we still need to do some deeply treatment to get water quality to meet the requirement of water resource as a normal drinking water resource, as a drinking water resource, so we can use that water source directly for our drinking water or some other purpose. So in order to get water from like really dirty water at level 6, we have very good quality water for our drinking purpose. So we developed the nanofiltration membrane. Normally, nanofiltration membrane can be used for actually in many areas for water reuse. But we developed a membrane for different purpose. For example, we can do different type of nanofiltration. We call them DF product. So those DF product features including like they have a molecular weight cutoff at in the range of 100 to 500 Daltons, and small molecule, again, it removes small molecules, molecule organics, and also actually can remain some minerals if we need for drinking water. Here's the unit looks like. And in this process, in the development of the nanofiltration membrane units, we also develop cheaper and nanofiltration membrane. So it's PENF is a nanofiltration membrane. So the PE nano membrane, just like comparing with the conventional nanofiltration membrane, so we just save lots of material, also just reduce the cost. We use the lithium battery PE separators to replace the woven and also about like the PS ultrafiltration membrane. Then we also can now we can just produce the membrane at like large scale, and comparing with the conventional nanofiltration membrane, we can see PENF element, the membrane area actually increased 20% to 100%. Also, just because a special just a special pattern on the surface, which also can minimize the membrane falling. So here is the PENF element comparing with the normal nanofiltration element, and the cost actually reduced to 50%, and also can increase the packing density. And the most important, actually, we can make that material almost everywhere in the world. And here's the different models of PENF elements. And here is the production equipment. Talk about like more why the PENF surface, why PENF element can minimize the ND falling, just because the special pattern formed during unit manufacturing process. So that special pattern actually is not like really hard to get it. Just during that process, it automatically get a surface pattern, and those patterns can minimize membrane fouling. So summarize the characteristics of PENF membrane products. So membrane thickness is only 20 micrometer, and the PE film is mass production, is easy to get it. So the macro turbulence just caused by a manufacturing process can minimize the fouling. And also membrane area just increased about 20% to 100%. And then also can be resistant to organic solvent. Here's some result from our PENF. So here just I only introduced about the two types of nanofiltration membrane. One is we call the DF30, so rejection rate of sodium chloride about 30%, and a DF90 is a rejection rate of sodium chloride 80%, above 80%. Just comparing with the desalination, actually, if we use nanofiltration process in wastewater or water treatment and reuse, we need to consider organics removal. So in this system, the result indicate we can like successfully to remove organics in water, and just with the different type of membrane, DF30 with a molecule cutoff 400, and DF90 is a molecule cutoff 200. So once we apply the nanofiltration membrane used for different purpose, we will just do some experiment from the laboratory and then see which one is more suitable for those applications. So this result, just only talk about DF30. So when we when we think about we use nanofiltration in a water treatment plant, it's not for all treatment plants. For example, we do not need to use nanofiltration in Sydney because the water in Sydney, Australia, because the water source is good, it's had a good condition. But once we think about using nanofiltration membrane for water treatment, the organics actually we normally consider about industrial chemicals, and also about the pharmaceutical and the personal care products. So normally they probably just in our water source, and also about EDC compounds. So from this result, so we can see actually DF30 has done very good job. At the same time, just because we do not want to remove those minerals, so actually we can keep minerals in our still keep minerals in our system. So now I will talk about one by one in different the application in different area. So drinking water, we consider about two parts. One is like a household purifier. So this kind of household purifier has been, we actually also, we supply those units in Australia. For some like special area, the water actually is a high like TDS, and also with some organics. So from that result, comparing with the our nanofiltration nanofiltration membrane unit, PENF, and the conventional nanofiltration membrane. So we can have like higher water production, and also like we can do the different salt rejection with a different membrane design. For treatment plant, as I mentioned, so if we talk about like briefly talk about like total the generation for drinking water treatment process, we can see 4 stage. Now, just like the current generation is like conventional coagulation, precipitation, filtration, and also the nanofiltration. So once we add nanofiltration in the system, actually we need to consider about like all protection or pre-treatment for membrane treatment. So actually we need to add the parts for nanofiltration process. I think it will increase the cost, but we get a better quality of water, but we also need to have some investment. Again, I need to emphasize that actually nanofiltration application, we need to consider those areas where the water source contains trace organics or disinfection byproducts, and also the areas where water sources contains heavy metal or other ionic pollutant. Those kind of contaminants are actually difficult to be removed by conventional technology. So in China, actually, we now just we just gradually to upgrade the water treatment plants with a different type of filtration process. But I'm sure in Australia we still can use the conventional treatment process to get like good quality of drinking water. Is not a problem. So for nanofiltration process, the performance, we can highly remove trace element, and then also remove about the total phosphate and aluminum and sulfate, and also can effectively remove it's called thallium, and also about some other magnet. And we can keep the TDS. We just remove less than 25% of TDS, keep the minerals in the water system, and keep the pH. No change at pH. Here's some application cases in China. So even though they use actually nanofiltration for like a small scale, it's not like really large scale as a water treatment plant, but those kind of improvement of water quality facilitate those process to meet the requirement, drinking water requirement in China. So if we see the different project, they actually use in different area and with a different scale and capacity, and just mainly just try to remove the contaminant of sulfate and some other maybe some other heavy metals. In summary of the achievement of like ultrafiltration plus nanofiltration, so we can see for the contaminant removal, we can can remove about like 60, 70, or 80%, 90%. For the minerals at total hardness, for the minerals, we can keep like low removal and keep those minerals in water system. Now we talk about applications in new water source. So new water source, I think is a concept we now be more and more using water recycle and water reuse. So just because we do not have enough, we got a water scarcity, and we got a more and more problem with the water, less and less water source. So we need to make more water supplements in short time. So now we developed the process as like MBR plus nanofiltration plus DF for like to make new water source. So this chart just talk about like the flow chart when we use ultrafiltration and nanofiltration in our new water source treatment plant. So the effluent can meet the level to meet the water level 3 in China. So which is actually can be used for drinking water source, but theoretically we can use that water for drinking water source. But actually we also need to do some more like natural treatment, just natural treatment, like just leave that water in the river for a time period, and then to use those water for drinking water source. Here's the whole flow chart for the treatment plant. So again, once we add the nanofiltration process, we also like add the cost. But just comparing the water quality, sometimes if we think about we do not have any other solution to have a better water quality, then the cost actually is a really like small effect. So here's the picture we call the tree hu. Actually, it's called a tree hu. It's a tree lake new water source plant in Beijing. Other engineering project we do for the new water source, including Kunming area, and also Xinjiang area, and also Qingdao area. They all just really concerned about new water source for the local water supply. So now we talk about like application in wastewater reuse. In this part, we just probably pay more attention to the ecosystem water supplement and industrial utilization. So once we have a very good quality, effluent quality after nanofiltration treatment, so we can use this water just to like make sure we can use those water for different purpose. For example, in Beijing, we have a reclamation, just a recycle reclamation water plant, and the capacity is pretty big. It's a 600,000 cubic meter per day. We cannot use that big amount of water every day, but we can do part of that for like a river water supplement. So for example, we provide 50,000 cubic meter per day in Beijing for Yongding River water supplement. We also provide water, get a part of water to provide water source for industry utilization. For example, we can do further treatment with CMF RO, is continued membrane filtration for like to produce the high quality water for integrate circuit manufacturing process. So then we don't have to use like tap water. We use this water just already meet the requirement, and then we can save our natural water source. Considering about membrane application, I think the question just we cannot use only membrane for everything. So we also developed some technology like combined technology with the membrane. So now we talk about like the chemical membrane chemical reactor, and also about the talk about its application. So a membrane chemical reactor is kind of process we developed actually in China, just for some like industry purpose, also for some local water treatment. So in this process, actually, we do coagulation and membrane treatment in one tank, so we can save space footprint, and also we can save the cost for more chemical dosage. And here's the comparison of like if we normally use a wastewater treatment, we do like a coagulation, sedimentation, and also sand filtration. Then we can add membrane in the system. But if we do like some especially small capacity or small site, we can use a membrane chemical reactor. Then we only use one tank. We do a different piping, but the container we only use one. We put a membrane in the tank, and also we can add a coagulant or flocculant directly straight away to the tank. So in this situation, we can save 50% footprint, and also we can reduce the cost for the chemical dosage and also the operating cost. This MCR can be used in different like area. As I mentioned, it can use for like local water supply, and also can use a small scale of industrial wastewater treatment and reuse. And here's the table we compare with other technology. So the performance at like low investment cost, and also small footprint, and for the inlet water requirement is pretty flexible. So we can adjust the membrane membrane unit, then it's easily to adjust to meet a different inlet water quality. Here's a real application case we developed in Beijing. The capacity is about 7,500 cubic meter per day. And see the inlet water solid is a really high, it's about like 10 to 15 gram per liter. So also in this process, because we can modify the, because only one container, we can modify the process easily. So now we also just make the equipment like integrated equipment. Just we can, that's mobile unit. We can move to different area for once we finish the treatment, they also can move that equipment to other place to for some other to finish some other job. So in summary about like the solution for the three water major problem. So membrane actually has done a very good job. It's a key technology to solve that three problem. So again, just for contaminated water, MBR technology is a key technology. And for water scarcity, we can use MBR plus nanofiltration. So for the unsafe drinking water, to treat unsafe drinking water, we can use conventional technology plus nanofiltration to fix that problem and to provide, ensure drinking water quality and safety. So all the work involved in this presentation was done in our R&D center. And here I would like to just have a grateful acknowledgement goes to the UNSW team for their contribution on the CFD simulation, and to the UTS team for their contributions on the pilot work. Thank you. Thank you for attention. Questions, please.
Thanks, Dr. Qingguan, the wonderful talk. Now we are open for question. We have one question. Dr. Jin, can you see that actually there are a few questions from the chat box?
Okay, I just can open that. So
yeah.
Chat box at the so the resolution.
The first one is from the
first one?
Hu. Yeah.
Okay. So the the future, actually, the future of industry wastewater treatment, I think just we probably need to like pay more attention about water reuse, just because like huge of water quality and quantity actually has been used in industry. So we need to classify the industry wastewater into different group, and also to treat water like by, for example, a membrane technology or membrane technology combine other technology for different purpose. So I think just we need to first we need to classify the industry wastewater and just apply the technology for different purpose treatment. And the second one, join us see. So the cleaning of DF 30 and 90, we still use like conventional nanofiltration process, but just because we control, we have complete like control system to minimize the falling. So the cleaning maintenance is the same way to the conventional nanofiltration. And the third one, Michael? For the EF membrane. So for the ultrafiltration membranes, just because that will depend on a different material. For our membrane, ultrafiltration membranes, normally the lifetime is 5 to 8 years for the replacement. More?
Any more question? Maybe I ask one or two. And you talk about the one membrane configuration, what do you call it? Corrugated.
Corrugated membrane.
Yeah, corrugated. You show actually the result. This membrane, this new configuration can, I think, stand for higher solid content, and it makes the membrane filing will be less. Could you explain a little bit, how it works compared to the, the normal hollow fiber or a flat shaped membrane?
Yeah, because this one actually is a combination of flat sheet and also hollow fiber. So once we develop that membrane, we just try to use the advantage of flat sheet and hollow fiber. So in that, so if you see the, so if you see the like corrugate shape that thinner and the lighter, and also that just kind of can have the advantage from flat sheet. Well, just we can see the like independent water production channel that actually from hollow fiber. So then we can once during the operation, so we can see clearly about like those hair and the fibers actually just minimize, just actually reduce and minimize those hair and fiber accumulation. Because otherwise they will accumulate those hair and the fiber to the top.
Oh, okay.
Yeah, that's the anti-falling functions.
Yeah. Very smart design.
Yeah, so it's take time actually, but it's really good performance now. Yes.
My second question is the membrane goes MCR, to combine the membrane filtration with the with the coagulations. How actually this I can understand this will actually reduce the footprint, but I do not understand how the chemical dosage is less compared to the conventional process.
Once we do calculation, when we consider about the sedimentation, so we need normally we do need to do overdose of chemicals. But if we do membrane filtration, or just do like even though it's an ultrafiltration membrane, we don't need to consider about like the particle completely settled. So we just need to make that like a judgment, as long as the particle won't clog the membrane, block the membrane. Those dosage will be good enough, and those dosage level will much less than the overdose. So actually we reduce the chemical dosage. I think that application just we also use for some other like MBR process, So if we only consider about the filtration, we don't need to consider about like settlement. So we don't need about like whether they completely settle. We can get water come out from the top. So it's a kind of a filtration process. We just, as long as we can make the particle good enough to be stopped, that will be good enough. Yeah.
Oh, thanks. We have two more questions from, I think, one is on YT and another is from Galax.
I just need to how to. All right. So
the photocatalytic membrane.
So where's the question? So from all right. I think photocatalytic membrane theory. I think ideally we can use that for wastewater treatment. We also can improve the achievement, but just because the catalysts are normally actually it's difficult to control whether it's stable during the process. So unless we really need to treat some special organics, I think just we only can use photocatalysts. We can't use some other process. I think this photocatalyst membrane will be tried used in a real wastewater treatment. For the current stage, we only combine with other catalysts with our membrane treatment process, but we won't use any photocatalytic membrane for the wastewater treatment. I think it need to take like time for some research or just some work in the pilot and see whether it's working okay for the real situation. And the next one
is economic analysis.
Economic analysis of this. So talk about like only these membranes. I think now we just try to minimize the cost for the application. So for example, like MBR process, we develop those membrane just to minimize the price. It's not very much, but it's not very much. But because so many company and manufacturing factories just are actually established, so because the mass production also can reduce the cost. And for the nanomembrane filtration, nanofiltration membrane, now we develop the PEDF, actually just reduce the cost a lot. Because when we use different purpose, for example, when we apply those technology in drinking water treatment, which is not very, the condition is not very tough. So we don't have to use very strong and membrane. So the PEDF membrane we developed and also applied very well in China for drinking water treatment process. So the cost is not a problem. So we do the economics analysis for those membrane application, because if we need to pay more money for the engineering project, nobody will ask us to do the job.
Thanks, Dr. Guan. Could you stop sharing?
Sorry?
Could you stop sharing your slide?
Okay. So
due to the time limitation, I think we couldn't take any more questions.
All right. Okay. Fine.
Yeah. I think before we close this seminar.